These are the notes for Scientific Method, Chapter 1, Sections 2 and 3. You need to have a pen and paper out and write down the words that I am saying and the words that are in red on the slides as they go by. You may want to pause before I go to the next slide so you can copy everything down. These notes will be no more than 10 minutes, but that does not mean that it's going to take you longer than 10 minutes to copy them down. When you get finished, you need to put them in your folder, and I will do note checks because this is a homework assignment. So you have normally a week to do these notes, but in this case, since you guys are all watching them on Schoology in class, I'm going to check them for the end of class and count them as a grade. All right, here we go. Process of science. Yeah, we're going back to scientific method. I know you've covered it a million times, but you guys never remember it. So we're looking at observations. Observations being made with your naked eye, with instruments. You need to make sure that you're doing this quantitatively and qualitatively, so that you can record what happens unexpectedly, and you can also share this with colleagues. The hypothesis, given usually in an if-then statement, but doesn't have to be. You want to be able to explain the phenomenon or answer a specific question by generating a prediction and saying this is what I suppose will happen because of this, this, and this. You need to either support or reject the hypothesis after you complete your data and restate your new hypothesis in your conclusion. All right, changing slides. Sorry, I know that last slide was fast. All right, gathering data. Yes, you need to write all of this down because there are really important vocab words in here we're going to use all year. So independent and dependent variable. I don't know why, but we get this all screwed up, and the answer is in the word. Independent variable, meaning that is independent from everything else. So it's what you change, not based on the rest of the experiment. The dependent variable is what changed because of what you changed. Yes, I know that sounded incredibly confusing, but bear with me here. So if you have a situation where you are changing the level of water in something, that's the independent variable. You change the water. The dependent variable is whatever's reacting to the water. So the fish living in it or the plant growing. Those are the dependent variables, and there can be more than one. All right, I'm changing slides. Make sure you have all 3 bullet points written down. When you're gathering the data, you need to make sure that you do it quantitatively and qualitatively. Quantitatively meaning with numbers. Qualitatively meaning doing observational points. It's looking wilted, there's brown color, doing a proportion, a percent, it's 50% brown. When you're doing quantitative data, you want to make sure that you have the data table and that you also have a graph. Changing slides. It's really important to do feedback to the community. In the picture, this is of the USGS. The situation that you're seeing is what's called a poster presentation. This is the way that a lot of the researchers give their presentations now. They print out a giant poster. There's 2 in the room if you go back and look around. And with this giant poster, they'll stand there and kind of do like a presentation and answer any questions that people may have about what's going on. It's really quite nerve-wracking to do a poster presentation. I've done 2 in my life, and it's, yeah, I'm nervous and shaking every time. All right, sorry for the really loud noise. The hypothesis is a testable explanation for a narrow set of phenomena, while a theory is a broader explanation for a wider range of observations. You need to make sure, oh, thank God, that you know the difference between hypothesis and theory. Both hypotheses and theories must be testable and supported with different types of evidence. The difference, big difference between hypothesis and theories is hypothesis is still being worked on. It's still being researched. A theory is something that's being presented to the scientific community and is being accepted as, not truth, but as more plausible. All right, scenarios. Looking at which experiment is better and how you would fix the experiment that is wrong. So I want you to read both of these, and on your paper, tell me which one do you think is better, A or B, and then what you would personally do to the experiment that is not the better one. How would you fix it? How would you do it differently? So go ahead, pause, read through these, find out which experiment's better and how you would fix the bad one.